What's going on, people? Mr. C here. We're going to be covering lesson 9.4, talking about arithmetic series. So basically, biggest difference between what we're doing today, so a series, it's not like, don't think movie series or TV series. Series is a new mathematical term. Basically, it's if we were to take all of the terms in our sequences, if we were to add those all up, we refer to that as a series. All right, so that's what we're going to be doing today. All right, so there's a formula we can use to find the sum of a series. All right, and it is this guy here. So if we were to add up all the terms in that sequence, again, we call that a series. You take n, which is basically there's two limits, right? In your sum, there's a lower limit and an upper limit. Typically, our lower limit's going to start at 1, and our upper limit's going to be some number we want from our first term to our 50th term, or our first term to our 100th term. N is going to represent our final term, okay? So, well, N is going to represent like the 100th term or the 101th term. It's not what the actual term is equal to, if that makes sense. I'll clear it up when we do an example. So this is my formula, n over 2 times the first term plus the last term. Okay, n over 2 plus the first term times the last term. So let's use that formula for this example here, right? Let's say we wanted to find the sum of the even integers from 2 to 100, right? So let's think about what is n. N is the number of terms that we have. So between 1 and 100, there's 100 terms, but if I cut that in half and only count the evens, there are 50 terms, okay? So n should be 50. My first term is given of 2, and my last term, a sub n or a sub 50, is 100. So if I want to find that sum, I can just, again, plug that into this formula here. Sum is 50 over 2 times 2 plus 100. That's going to be 25 times 102. Calculator, 25 times 102 gives me a 2550. All right, 2550. Okay, and that's how we use that formula. There's an easier way to write series rather than just doing like a full sentence here. Okay, so there's something called summation notation. Summation notation. Summation notation looks like this. Okay, we refer to this as a sigma sign. Okay, and we write our two limits. The lower limit we write below. Okay, and the upper limit we write above it. Okay, and then we write a rule for our terms. So this is an example of summation notation. Again, we have our two limits, a lower limit and the upper limit, and then our rule for finding the terms, right? So this is saying add up all the terms from 1 to 70, and you're plugging in, say, 1 for 5, and then plugging it in to get your first term. So again, a sub 1 would be if I plug in 1 for n, 5 times 1 is 5, plus 8 is, or sorry, plus 3 is 8. A sub 2 is, if I was to plug 2 in for n, 5 times 2 is 10, plus 3 is 13. Right? I don't need a sub 2, I just wanted to show you. Okay, what would my last term be? A sub 70. Well, that's 5 times 70 plus 3. Let's think, what is 5 times 70 plus 3? 353. 353. Right? And from here, we can just go ahead and use that formula to solve that again. Remember that formula was, okay, so this whole thing is going to equal n over 2. N is 70, my upper limit, times my first term plus my last term, which is 8 plus 353. So what is that, a 35 times a 361. Okay, and we get a 12,635 for my answer. All right, so that is summation notation for that one. And that is it for today. That's all I wanted to cover. And this will cover both days, so I might just do one. I'll split it up into 2 days so you guys still have it because I want to stay consistent. But yeah, kind of a shorter lesson today. Hope that makes sense. Hope you guys followed. If not, let me know. Leave me a comment, question, whatever you got to do. So, all right, miss you guys. We'll talk to you later. Peace.